So this question does it seem hard or easy?
Hard.
Hard.
Well,
Alright, so
it
maybe
seems, I don't know how to explain. It seems very, very doable. I just don't know how to do it.
like it might seem hard because there's a lot of sort of new terminology and stuff, but like this is the kind of stuff that you can probably like get better with even from school just because you do a lot of polynomials and curve sketching and stuff in school eventually. Maybe it'll never happen. It's always a promise. Okay. Always, oh, next year we'll do something. No, okay, so we're looking for a polynomial. So if you sketch the x, so this is like the x-axis, right? This is like the y-axis. Okay. And so this is like the y equals 2 line. And this is like the y equals minus 2 line, right? And then we can take like, so originally the problem was originally the problem was to show that if you can get it within like 2 and minus 2, then you can get it from 1 to minus 1.
Yeah.
But I kind of just skipped that first part because um, it's kind of obvious that if you have 2 to minus 2, you can just have like y equals x. Y equals x does that, right? Yeah, so that'll like kind of keep the interval the same length. But so if it's a little bit less than 4, it'll be a little bit less than 4. Yeah? Okay. And then you can think of stuff like like this. So if you do y equals x squared, right? Like y equals x squared, it'll kind of look like y equals x squared. It'll kind of like go up to 4 and go up to 4, right?
Yeah.
So it'll kind of look like that, yeah. Okay, but I think it's nicer if you shift it down by 2.
Yeah.
Okay, then it looks a bit nicer. It looks like this, right?
Mm-hmm.
Yeah.
Yeah.
So this is y equals x. This is y equals x squared minus 2, right?
Yeah.
I think it's really good to try to draw a lot of these things. You can actually fit a cubic in here too. We actually had one that was like
x cubed minus 3x.
So you had like a y equals x cubed minus 3x. Yeah. And it kind of looked like, so what happens when you sub in 2? You get 0, or you get 2, right?
Yeah.
If you sub in minus 2, you should get minus 2. So it kind of looks like, it looked like, and at 0, it's 0, yeah. So it might actually, I think it looked a bit better than that.
No, I think it was tangent.
It touched at 1, yeah?
Yeah.
It's quite remarkable, really. It touched at 1. Okay. Okay. So I'm kind of claiming that all you really need is the x squared one. Okay. Let's do this. So what's good about the x squared? Like, what's it like? If you think about the x squared one, right? What's the difference between the x squared one and the x? Yeah.
Yeah.
The x keeps everything the same, right?
Mm.
So if you make it 2, and then you make it a little bit less than 2, it's not going to make a difference, right? It's still going to end up just a little bit less than 2, right? But for the quadratic, it actually makes a difference, okay? And same with the cubic, but let's just focus on the quadratic, okay? Let's focus on the quadratic. So the quadratic like that, yeah? Okay. Well, the kind of interesting thing about the quadratic is it goes up much faster than the straight line, right? So here, if you focus on like this area here, right? Like you're only going across a little bit, yeah?
Very much.
but you're going up like a lot, right? That makes sense. So then when you cut down from 2 a little bit, right? The actual image cuts down by more than that little bit.
Yeah.
Does that make sense? And that's basically the key idea, okay? So one thing that's kind of nice about functions, have you heard of composition of functions? So basically you have a function, right? Goes here, right? And you have another function that goes here, right? What's like the most obvious way to get a function that goes here? Yeah.
Go from 2 square then to that one.
Yeah,
FG.
you do f then g, right?
Mm.
It's called composition of functions. That's the most natural operation of functions. Yeah, people will tell you how to multiply and add functions, but that's only because you're dealing with domains and stuff, codomains where you're adding it. You can add stuff. Yeah, but if you just have sets, like this is the most natural operation. You just put one function after another. Yeah.
Mm.
All right. So, for example, so if I'm putting in, so at the moment, so if I'm putting in like 2 minus epsilon and minus 2 plus epsilon, right? If I'm putting that into this function, yeah?
Yeah.
Can you see what it gives me? So this is y equals x squared minus 2, yeah?
So putting something in that domain in, right?
Yeah.
Gives you what? The highest point of which it's 2 minus epsilon squared minus 2.
Yeah. So the extremities will be 2 minus epsilon squared, right? Minus 2. And it'll be the same on the other side, right?
Yeah.
And it'll go from minus 2 to that, yeah?
About the extremity.
So do you know what this notation means?
It's like the XY axis.
So this notation means like all the values between minus 2 plus epsilon to 2 minus epsilon, inclusive. So here we're talking about these are the x values here. And for these values, these become the y values.
Oh.
Okay. Yeah, so it's like, this is also in the HSC syllabus now, interval notation, but it's kind of new. And I think it's even more confusing when you write intervals like this. So when you have the curved line, it means it doesn't include the end.
Okay.
If you have the square bracket, it includes the end.
Yeah.
So you can see why this is confusing because it looks like a coordinate, like a pair of points.
Oh.
But in the context, it should be clear what the notation means. Yeah. Okay. So basically, what I'm saying is, like, if I input values from 2 minus epsilon to minus 2 plus epsilon, right? Then the output here, right? That should be 2. They have the same output line, right? It should be 2 minus epsilon squared plus minus 2. You know? Okay, and then so obviously the outputs will just be from that to minus 2. You know? Yeah. So the actual length of the interval is just 2 minus epsilon squared. Yeah. Okay, so 2 minus epsilon squared Okay, what is that? Wait, this should not stump you.
It's like
4 minus
um,
4
4
epsilon plus
plus
epsilon.
epsilon squared.
Right?
Yes.
Okay, so what was the interval length before? Like, what's the length of this interval?
The length of that interval is 2 minus epsilon. Wait, no, I am suffering mental. 4 minus 2 epsilon.
Yeah, 4 minus 2 epsilon, right? So an interval of length 4 minus 2 epsilon just became an interval of length what?
4 minus 4 epsilon plus epsilon squared.
Yeah. So can you see also, like, you don't really care about the epsilon squared. Because, like, if epsilon's small, then, like, epsilon squared is super small.
Yeah.
Right? So this is roughly just 4 minus 4 epsilon.
Yeah.
So can you see that what that does is it shrinks down, it shrinks it down, right? It further than, so you're putting something in, and you're getting something out that's even shorter than what you put in, right? So can you see you can actually just put it in again?
Yeah.
You put it in again, and it gets shorter again, right? Yes?
Yes.
And you keep putting it in again and again and again, it gets shorter and shorter and shorter, right? Okay, so one issue you might think you would have at this point is like, well, I know that a parabola, so like I'm trying to take advantage of this steepness, right?
Yeah.
Yeah. But what if I get down to the bottom, it's not steep anymore, right? Yeah. That
Yeah.
could be a problem, yeah. But you should remember that this is 1. The non-steepness happens at 1, right?
Yeah.
Because when you square like half, it turns into a quarter and stuff like this. Yeah?
Yeah.
Okay. But actually, but at 1, the interval length is only 1.
Yeah.
Okay, so that's already far, because the interval that you want to get into is 2, right?
Yeah.
Because 1 to negative 1 is length 2. So when you get to 1, it's already far beyond what you wanted already. So you never actually get to this problem. Okay. Okay, so if this seems a bit too abstract to you, let's just do some like actual number calculations, okay? So imagine if your interval is like from, try to keep this picture here just in case. If your interval is just like name a number between, just name a number,
Root 2.
root 2. Okay, let's be more concrete here. Minus 1.4 plus 1.4, yeah? So this interval is more than length 2, yeah? What happens to it when you input it into this function? Goes to
1. 4 minus 2.6 plus 0. Wait.
4.
Wait, what?
Oh, you're doing 2 minus 0.6.
Isn't that what we have? 2 minus epsilon?
Yeah, but what's like 14 squared?
49 times 4.
Yeah. And it's gonna be close to 200, right? Because it's root 2, yeah?
Yeah.
Okay, so if you square it, it becomes 1.96, right?
Yeah.
Which at first might look weird because now it looks like it's bigger, right? But the whole interval is of length 1.96 now.
Yeah.
Yeah? Does that make sense? So if you minus 2 from that, it really goes from minus 2 to like negative 0.04, right? What the? Okay, so then you can kind of add a constant to make it
1.4
centered.
and 1.4.
Yeah. So if you add a constant, you can make this like minus 0.98 plus 0.98.
Yeah.
Yeah. And notice that's what you wanted,
and you just
right?
keep oh yeah.
Okay. If you're not convinced by this, you want another example?
I'm convinced, sir.
It seems like you don't care if you're convinced or not. Can you care a little bit, please?
I'm convinced.
Well done, Liam.
You're short.
I feel like this is like sometimes it's like someone's like you're trying to save someone from falling off the edge, but the other one's not even gripping stuff. It's like you have to grip as hard as you can and try to like not fall and stuff.
Yeah.
Whereas you're kind of like, oh, it's over anyway. If he saves me, he saves me.
Liam happily jumping off the edge.
Yeah. Okay, give me a number, Slava. Give me a number.
2.
Oh, I can't do 2. This is maybe the next part of the problem.
1.
Yeah, I know you got the part B to that. Anyway, 1.9999999.
1.
Really?
1.9.
1.9, huh?
Yes, sir.
1.9. Alright, so you can kind of see from 1.9, right? The square root is like 3.61, yeah? That already jumps down significantly. So the length of the interval from minus 1.9 to 1.9 is like 3.8, right? Right, I'm confused now.
So, you were... Oh, yeah.
Alright, so the length of this interval is 3.61 now,
Yeah.
right? And it's from minus 1.805 to 1.805, yeah?
So you get minus 0.4. No, that's not the length of the interval, sir. Oh, wait. Is it?
You can shift it so this is the
Sure.
interval, yeah?
Isn't it minus 0.1 or minus 0.4 plus 0.1?
Minus 0.4. What are we talking about here?
Yeah, because it's 2 minus epsilon, 2 plus epsilon, right? This will never get below 1 like the other one did.
Well, we don't need it to go below 1. We just
Oh.
need to get it smaller.
Oh, yeah.
And that one will get smaller. And then that one will get smaller.
Yeah, but it'll approach 1.
No, it won't.
Oh, wait, no.
We just
I'm
demonstrate.
high. I am high.
I mean, you can continue with the calculator, or can we just assume it's like 1.8?
We know it will reduce. We don't need to calculate it. We know it'll work.
Don't listen to this guy. We need to calculate everything, okay?
Once you know it will work theoretically, that's all that matters.
I feel like
I'm
the mentality behind these kind of things is like, at the end, would you bet like your life on it?
Yes, I'll bet my life that it works.
Oh my god.
I mean, he doesn't really like his life anymore.
No, I think he's got a gambling problem.
Oh, don't me.
No, I don't.
Though he did win the last bet.
Yeah, exactly. No, but this one.
But after winning the last bet, he's still in debt like 3 labor hours.
Yeah, but that's
Let's
because
just
I
be clear.
chose to donate 7 of my labor hours to you in exchange for pizza. Yeah, but sir,
Yes.
in maths, you can very much bet your life on things without concern because maths is rigorous, and you know it's true.
Yeah, you like
I'm not wrong.
yeah, in principle you should be able to, right? But like
I think you should bet your
in
life on
practice,
that,
people fake solve question 1 all the time, okay?
Liam, you should definitely bet your life on that.
Oh, can you get me one too?
Here you go, sir.
Thanks.
Hey, Liam, can I have one as well?
Oh yeah, get everyone one, yeah. What the?
Yes, this is communism.
Alright, you guys got Liam to think for that.
Oh, this.
Wait, you go to Knox, right?
Yeah, we got a shitty.
Oh. There's only 2 Knox. There still are a bunch of Olympiad people at Knox, aren't there?
I don't know why is it when I see Liam, I think I need to take my medication.
Maybe it's because he needs to take his medication.
Ah, yes.
But
What is this?
I give you blood clots? That doesn't make any sense.
I wonder what school you go to, Liam.
It's on your jacket.
Oh, okay.
Alright, people, let's keep it.
Whatever, the one person on the live losing things. Oh,
Wait, so
yeah.
roughly, okay, that's roughly like 3.24, right? Yeah?
Yeah.
So then the interval is kind of like minus 1.62, 1.62, yeah?
Yeah.
And then you can see that's like 2.56 or 2.6 or something, whatever, right? And it's getting to like 1.3, let's say. You can see where this goes, right?
Exactly. You would bet your life on this.
Hey, Liam, you should do some weightlifting.
This needs more weight.
Okay, so if you look at, so does that make sense? So then if you keep doing this, so I guess one thing to note is that the end, like we're using the quadratic, right? But the final answer isn't quadratic. Actually, you can prove that like a quadratic can never do something like this. Okay, and the reason is because
Because when you apply it again and again, it changes its degree.
yeah, so a quadratic. So there's a nice thing to know about quadratic. Every quadratic, like monic quadratic, okay, is essentially the same. Does that make sense? So every monic quadratic is exactly the same, but kind of moved around. That makes sense because of this completing the square business. So if you kind of got a monic quadratic and you add x's and constants, right? All you're really doing is just moving it around. But it has exactly the same shape.
In a gap of 2 is
I mean, so there's no way like it'll fit into this gap if you're just moving it around, right? Like it's already fitting it as best as possible, and you move it around, it's only gonna stuff it up.
But you know why I chose root 2, right? In regards to quadratic.
Why?
Because root 2 exactly maps to the 1 minus 1.
Really?
Like, root 2 is the maximum you can fit in there.
Mm.
Because it squares to 2 exactly.
Oh, okay. Well, that's good. So if you do minus root 2 to root 2, right?
Yeah, it goes to
It goes
2.
to 2, and it's a length, an interval of length 2.
Mm.
Okay, so the quadratic is not enough. But remember, what we're actually doing is we're using the quadratic over and over again, right? So which will eventually get you a polynomial that looks kind of like. So this is by no means the proof writing, but like I think the idea for us is more interesting right now. Yes.
Yeah.
Where is it? I've lost it. Yeah. So you might have like 3.61, right? It goes from minus 2. So then you might want to put it like it's like x squared minus 2, right? And then you plus like like plus 0.2 or something to give it from here to here, right? And then you put it into here again, right? Minus 2. Yeah. And then that'll give you the 3.24, okay? From minus 2 to like 1.24. So then you want to get to minus 6, 1.6, you got to plus like 0.4 or 3.8 or something, right? Yeah, to center it. And then you put it in again, right?
Yeah.
And get to like 1.3, the plus 0.7, and then you put it in again. You see how this works?
Yeah.
So the nice thing about composing, it keeps it monic, right?
Well, this is your idea from before, but actually works. But remember that one you had on Friday?
Um,
Similar. Like the squaring again and again.
No. So the thing about Friday is like nothing could work because we were actually trying to prove something that wasn't true. So like if it was just two and minus two, okay, and you want to get it below one, I don't think that's I actually don't think that's possible. Okay, you need a little bit less than two to get.
Yeah, that's what I thought.
Okay, so actually there's a part B to this problem that's kind of interesting. It's like what what value do you need, right? So like such that no matter what you do, you can't get it less than one, right? And so the conjecture that we have is that it's two.
Yeah.
Okay. So we're saying that if you have minus two to two, okay, it's impossible to get this um, into minus one
It's possible to get into -2.
and one. Yeah.
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 Have
So,
you proved anything you can get into 2 -2 you can't get into?
yeah. Like
You can get into -1 1.
yeah. Basically.
So I think if it's greater than 2, it feels like that might cause issues to what you did earlier with squaring.
Yeah.
Because 2 or greater, yeah, expands the interval rather than shrinking it.
Yeah. So if you want, you can think about this problem a little bit. But basically, it's like if you have the interval from minus two to two, yeah.
Yeah.
Show that you can, with a monic polynomial, you can never get it within 1 to minus 1. Yeah? Like, can you even get it to be equal? I don't know. Can you get it to be equal?
Equal, maybe. Well, you could get it equal with a polynomial of infinite degree.
Huh. Interesting statement.
It's just my intuition because as you repeat your thing, like you can get closer and closer and closer to it. Wait, no, I don't think you can get it into that. Or it's not using your method.
My method. I don't have a method for this.
No. Your method for things less than 2 does not work for 2.
Okay. I don't want to spend too much time on this because they will have to go at like, well, maybe we'll have a bit earlier lunch. We'll have a bit earlier.
Right.
Okay.
You should tell that to Slava. Tell it to Slava.
Yeah, I think there should be something very fundamental that solves this part. Something
It's like theory.
I don't know. I think it should be pretty simple. Like, I mean, if you just consider like a big power of x, right?
Yeah.
It's gonna take like -2 to 2 to like it's a huge interval, right?
Yeah.
And then you're subtracting like the next smaller power x.
Yeah.
So then maybe it might make sense to understand how like how the intervals will subtract with each other. But yeah, I guess the reason I went on to solve the other problem is because people were very interested in it and got a bit stuck. But I don't think I'll tell you the answer to this one until something similar happens.
Mm. Because the interval's much greater, I don't know, this isn't rigorous at all. But if you substitute in, you have like the minimal thing, Michael, like the constant part of the polynomial is obviously less than -1 or +1 in effect, right? And you can basically, it seems like if you look at the amount of terms, like their coefficients, the ones which are positive versus negative, the negatives compared to the positives get significantly larger for 2. Like,
I don't know, like for example, if you have a polynomial, right, and you add a constant,
yeah.
like that doesn't change the interval at all. Like
Yeah.
the length, right?
Mm.
You're just adding a constant, the length of the interval doesn't change, right? What happens if you times the polynomial by x?
That can change the length of the interval.
Yeah. I actually think fundamentally this is kind of what we're doing here. Like what happens to this length of the interval when you times it by x?
Wait, Michael. Oh, right. Yeah. The range 2 to specific. If you want 2 to fit inside 1 minus 1, the amount of ones versus the amount of positive coefficients compared to the negative coefficients needs to be significantly more negative. Because when you wait, actually I don't know how else.
Like let's just think of some examples. So if the polynomial outputs like something like it's like it goes 2 to 5, yeah, it does something crazy like that, yeah. Okay, what does timesing by x do to that? And x goes from -2 to 2, yeah. Is it obvious what x does to this interval? I feel like this solves the problem, but
Yeah.
I don't want to spoil too much, but I feel like it's inevitably being solved as we talk about it.
Yeah.
You can
It's
consider
not-
it would be called a live solve, I guess.
You can't reduce the interval of 2 minus 2. There's no way to reduce that interval. Like the interval of 2 minus 2 always has to be at least 2 minus 2.
I feel like you're missing what we're doing. Yeah. You like to jump to conclusions, but I like making little progress, little steps of progress. So if you have an interval 2, 5, yeah,
Mm.
and you map that by multiplication by x, yeah,
Mm.
what interval do you get?
2x, 5x. Actually, I'm not high.
You need to think before you talk. This is the
3x. Wait, what the heck?
x goes from minus 2 to 2. Yeah.
Yeah. Oh.
It's like it's okay to be wrong, but like if you just answer instantly and it's just like retarded. Like you know what it means to times by x? Actually, this is like a little bit even like you don't actually get all the value from 2 to 5 times the x, right? You only get the thing that the polynomial actually outputs, yeah?
Yeah.
So, but we can be a bit generous and say it outputs all of those things and see what happens if you times them all by x, right? This will give you an even bigger set, right?
Yeah.
Like, what's the smallest and biggest values that get output here? Sometimes I look and you're not really even like, you're not even. You're not even stuck on the problem. Like,
Is it like -10?
yeah, I think so, yeah.
Yeah.
What do you guys think?
Yeah.
Because if x is minus 2 and you times it by 5, it's going to be minus 10, right?
Yeah.
So I guess the trick is it's not minus 4. Yeah, that's the first layer of this. And then when x is the biggest, it's 2. And the thing is, when x is biggest and it's 2, it actually probably does correspond also to when that's biggest. We don't necessarily know, okay? Because it could happen somewhere in the middle where it's like a extreme thing. Okay. Yeah, so the argument isn't quite great. So this would take it to minus 10 to 10. I mean, if the interval length, yeah, if the interval length was always getting bigger like that, then that would solve the problem, yeah? But the issue is the endpoints might not be where the maximum and minimum are, right? It could happen in the humps in between. Okay. But Yeah, so I guess there are some issues here. But if this argument were to work, you know how the argument would work? Like you take any polynomial, right? So think about a polynomial like x to the 5 plus 3x to the 4 minus 2x cubed. You know what I mean? Yeah. So how would you kind of break this polynomial down? Yeah. One idea might be to be like, well, whatever interval this maps to, right?
Yeah.
You kill the 2, it'll have the same length, right? And then you can take, when you kill the 2, you can take out the x, you know? Minus 2x squared minus x. Okay. Oh, what? There should be like an x. Maybe like plus 1 or something. Plus x.
Take out. Yeah.
Hmm. Okay, so it's a little bit worrying because when the plus 1 here, so ideally I would like to try to take out the plus 1 and take out another x, right? But the issue here is the one, like shifting it does change how x interacts with the interval, right? And though, you know, it might not be too bad because if there is a plus 1 there, like x will, like the interval will be like something. It could even be negative, I guess. But I'm kind of thinking of it as x times plus x to the 4 plus 1. And this is x cubed plus 3x squared minus 2x minus 1 plus 1. Like this. And keep going until it kind of looks like you know. Alright, let's cut this. Let's just see if what happens if it's just like at this point it's just x minus plus 2 or something, right?
Yeah.
So I guess if it's like that, then it becomes kind of a bit easier to see what's happening to the intervals, right?
Yeah.
Because x plus 2, like, it's just got the same interval as x, right?
Yeah.
But it's going from 0 to 4, yeah. Okay, and then when you times it by x, well, we know that the extremes are where the extremes are, where the maximum minimum. So when you times by x here, you do get like minus 8. Oh wait, you don't actually quite get minus 8 to 8. So you get I think you get more like 0 to 8, right? That makes sense?
Yeah, because you don't have the minus to multiply.
Yeah, like the minus 2 is multiplied by 0. Okay, and then you subtract 1 from that, so it becomes minus 1 to 7, right? Yeah. And then you times it by x again. So here it's yeah. So at the moment the minimum values are corresponding to the minimum to the ends, and the maximum is corresponding to 7. So at the moment, just doing timesing this by -2 and that by 2. Yeah. I don't know, so that could be a problem because that'll be 2 to 14, right? So maybe we can try to think of a way to make this fail. And then you plus 1 again, right? So there's 3 to 15. And then you times by -2, it's -6 to 30. Yeah. So it's gotten way bigger.
Yeah.
Okay. Like, how can we try to make this fail? Let's see. I guess the point is it starts with an interval that's already bigger than 4, right?
Yeah.
So, like, I think one of the issues here is, like, if the bottom number is negative and you're timesing by -2 and the top number is positive and you're timesing it by +2, it could end up as the same number, right? So, like, what if you just started with x and it was -2 to 2, right?
Yeah.
And then you times it by x. So, like, it would naively look like you're going from 4 to 4, right?
Yeah, but that's impossible.
But it's actually going from 0 to 4, yeah? But now the problem is the 0 is in the middle. Okay. Yeah. Yeah, I guess if you can kind of keep track of where the stuff's happening. Because if you times by x, it's always going to have a 0, right? So as long as the numbers on the outside's bigger than 1, right? Like, one of them has to be bigger than 1, you know what I mean?
Yeah.
Then, yeah, so there's like 3 kind of points of interest. And then you shift it by 1. Yeah, so actually, this approach, I feel like, is strong enough to solve the problem, okay? And the reason is because it tells you exactly what's happening, you know? If you can't, but the trouble is with, at the moment, why it's not hasn't solved the problems, because we haven't dealt with all the issues, you know?
Yeah.
But if you can keep track of what's happening, and usually it's too hard to keep track, but the point is here, it starts very simple, right? It starts literally with x, you know? Yeah, and so the thing is, every time you times by x, like, basically the interval stays pretty big, yeah? Okay? Provided it started pretty big. And there's some catches, you can't just time the first and second number because it could end up with 4 and 4, right?
Yeah.
But every time you times by x, you always get 0, right? So you don't have this issue with positive, negative numbers being the same because you still always get down to 0, right? Because if you times by x and you sub in x equals 0, you get 0.
Yeah.
Right?
Yeah.
Okay, and then, but the thing to watch out for next time, I guess, is, so the next time the interval is a little bit different. It's like going from 0 to 4, but the 0 doesn't happen at -2, right?
Yeah.
The 0 happens wherever, the 0 happens at 0.
Yeah.
You know? But then it's not exactly hard to predict what happens when you get 0 to 4 and then you keep,
Yeah.
like, So let's see what happens. So what you could, for example, subtract 2 or something. Let's go with add and subtract. There's two options, yeah? So it could subtract. It could go like -1 to 3. Yeah?
Yeah.
So now when you times it by x, you can see like it'll go from 0 to 6, right? See what I'm saying?
Yeah.
Yeah, so instead of kind of keeping track of what happens at the ends, you're keeping track of what happens at 0 and the ends. Yeah. And so as long as one of the, because one of the sides has to be more than 2, right? Because the interval starts off minus 2 to 2. So like it could be like minus 2.2 and then it could be plus 1.8, right?
Yeah.
But then this side becomes
4.4.
Actually, hold on. So that's not quite right. Let's see. Wait, if that side corresponds to 0, that's kind of a problem.
No, but you can also have either side be 0. So.
Can you?
Yeah.
Why?
Because
look, it multiplies the positive ones, right? That becomes positive, correct?
Hmm.
So then you just get that there's a value such that you can reach that. So it's the maximum. And if it's negative, you can just replace the positive with it. And say you get a negative like -6 and then something, you can just replace the other even value with 0. There's no real.
Hmm. Wait, how do you solve this?
how do you solve
This section? So what happens if it goes minus 2.2 and 1 plus 1.8? Or even just like minus 3 and 1. What happens there?
when you multiply that, it goes what? You get and the -3 that becomes 6, right?
Why?
Wait, does it? Or -6?
No. This is kind of the issue we're trying to. Because now the -3 corresponds to 0, right?
It doesn't need to.
Well, how? What do you mean?
Wait, why does it need to correspond to 0?
Because you started with 0 minus 4, with the 0 being here and the 2 being here, right?
Yeah.
So when you subtract 3, yeah, it's going to correspond to x equals 0.
Yeah.
And like these numbers still correspond to 0 and 2, right? Okay, we might leave this one there because I need to get through something else before David leaves. But maybe you can think about this more on your own, yeah? You see that there's some ideas here that could be quite helpful. So the promised